Okay, we're back to our review for the Chem 4 final. We're up to part 11, and that's on Henry's Law. Henry's Law and Raoult's Law deal with how much gas goes into solution. We're going to start by looking at Henry's Law. In Henry's Law, you have a gas above a solution. The more gas you have above the solution, the more gas you're going to have in the solution, because the gas exerts a partial pressure in atmospheres down on the solution. Let's look at the formula. The formula for Henry's Law is C, small c, which stands for solubility, how much gas is in there, in the water, in the solution. And C has the same units as molarity because it is a concentration, just like molarity. So it's moles per liter. C equals K, that's our solubility constant, times the partial pressure, again, in atmospheres. So the higher the partial pressure of the gas, the higher the concentration of the gas in the solution. The lower the pressure of the gas over the solution, the lower the solubility or concentration of the gas that's going to go into solution. So you need to remember that this is molarity, so it's molarity for the units. You need to remember partial pressure has to be in atmospheres. One more, remember, if you need to convert atmospheres, torr, and millimeters mercury, 1 atmosphere is 760 torr. It's also equal to 760 millimeters of mercury. So let's look at a Henry's Law problem. They're going to give you the Henry's Law constant. That's the K. They say the Henry's Law constant for carbon monoxide is 9.73 times 10 to the minus 4th moles per liter. Why are they giving us moles per liter? All right, we keep going. They're telling us it's 25.0 degrees centigrade. They want to know what is the concentration. Remember, think molarity for concentration. In this case, solubility. What is the concentration of the dissolved carbon monoxide in water if the partial pressure for carbon monoxide in air is 0.015 millimeters mercury? Right away, an alarm should be going off in your head. None of the problems in chemistry have millimeters mercury. I'm going to go ahead and fix that right now. So we have 0.015 millimeters of mercury, and we know there are 760 millimeters of mercury in 1 atmosphere. These cancel. So what are we left with? That's going to be 1.97 times 10 to the minus 5th atmospheres. Ooh, I'm glad we caught that error before it happened. I'm going to cross this out. So we have carbon monoxide gas over a solution of water. They want to know what's the molarity or the solubility. Here's our formula. C equals Kp. They gave us the K, right? 9.73 times 10 to the minus 4th. And they gave us we fixed the pressure. Oh, Kp duty. Henry's Law. Henry did Kp duty. 1.97 times 10 to the minus 5th. It's funnier when I'm in front of a class. So our solubility is 19.1681 times 10 to the minus 9th. We're going to do our SUN, significant figures, units, and number. We have number. Units, you know, it's concentration, so it's going to be a capital M, or moles per liter, or moles, liters to the -1. For significant figures, we go back to our problem. 3 here, 3 here, oh, 2 here. There was 2 significant figures here, 0.015, start and end. So we need our answer to be in 2 significant figures. So our solubility is going to be 19 times 10 to the -9th m, or moles per liter, or mole liter to the -1. All right, so regarding gases and solutions, we have 2 laws. Henry's law that deals with how much of this is going to go here, what concentration of gas is going to be in the water, and in our next video, we'll look at Raoult's law, which again deals with gases and solutions.
Done? Done?
Yes.